Hey everyone, it's Traxler. Sorry I'm not there live. I'm out of town with my daughter getting some stuff done for her for school. Um, so I have moved. I'm moving everything that was due this week to next week to give you plenty of time to do it. I'll definitely be live on Friday, so hopefully you'll be able to ask some questions then. But I thought we'd try and finish this lab up real quick. So if you remember, on Monday we took our calorimeter and we added a chemical called sodium hydroxide to it. And when we did, the 75 milliliters of water that were in the calorimeter rose in temperature from 19.7 degrees Celsius up to 36.1 degrees Celsius, a positive change of 16.4 degrees Celsius. Because the temperature changed, we know heat was added to the water. We have our equation, Q equals Sm delta T. Therefore, we know in order to raise the temperature of the water in the calorimeter, we had to add 4.18 joules of energy for each gram of water in the calorimeter and for each degree Celsius that the temperature went up. We had 75 grams of water in there, and the temperature went up by 16.4 degrees, meaning the water absorbed 5,140 joules of energy because our substance melted. Cool? Then, when we ran out of time on Monday, I was going to do the same thing for ammonia nitrate. Now, dissolving, unlike melting, can be endothermic or exothermic. And ammonia nitrate, it turns out, is endothermic. It requires more energy to get it to dissolve than you get from it dissolving. That tells you that more energy has to go into breaking the bonds holding it together. So the bonds holding ammonia nitrate together must be stronger than the bonds holding sodium hydroxide together. So, excuse me. So our starting temperature is 19.7 degrees, and our final temperature is 5.3 degrees Celsius. So notice our temperature goes down by 14.4 degrees Celsius, which means heat had to leave the water and go into the ammonia nitrate. And we use that same equation, Q equals. Now, in this case, the water has to lose 4.18 joules of energy for each gram of water and for each degree Celsius that the temperature goes down. We still have that same 75 grams of water in there. We measured it out. But now the temperature is going down by 14.4 degrees. And so we would say that heat is lost by the water. And do the calculations. 4.18 times 75 times 14.4 negative 4,510 joules. Okay, so notice dissolving can be exothermic, can give off heat, or endothermic, can take in heat. And what it is going to depend on what chemical dissolved. So every time you dissolve something, it's either going to give off heat or absorb heat. So we can put those two things together. So notice this is in kilojoules, but it refers to that whole reaction. If we divide the amount of energy gained or lost by the amount of substance that dissolved, which was in both cases 5 grams, then we can get a number that we call the heat of solution. So for NaOH, 5,140 joules of energy were given to the water when 5 grams dissolved. So we get 1,000, just 3 significant figures, 1,030 joules for every gram of this dissolved. So if we wanted to heat something up, we could add a very specific amount of NaOH. We can do the same thing for ammonia nitrate. But in this case, it's energy given that has to go, energy has to leave the water. And in this case, 4,510 joules of energy for every 5 grams that dissolved, or 902 joules of energy per gram. And we actually use this all the time. So if you've ever had one of those, been injured in sporting, and they bring out one of those cold packs and they break it open, it is literally filled with ammonia nitrate. And by how much ammonia nitrate they put in there, they can figure out how cold that packet is going to get, so that it doesn't get too cold. It gets cold enough to relieve some pain, but not so cold that it burns you. Same with NaOH. We know how much of it will dissolve. So we put this in things like MREs, military ready-to-eat meals. They come with a little pouch that you can heat up the food in, and it has a specific amount of NaOH, and it will give off a specific amount of heat. Cool? If you were listening, I answered both of these questions a minute ago. So now I thought I'd throw in one good hard question, and that is putting together both of the calorimetry labs. So on Friday, we learned that it takes about 330 joules to melt a gram of ice. So let's say your driveway is covered in ice. How much NaOH would you need to melt it? Well, first we have to figure out how much energy is needed to melt the ice. So we have 5,000 grams of ice, and it requires 330 joules to melt each gram of ice. So 5,000 times 330. So it's going to take 1,650,000 joules of heat to melt the ice on your driveway. So let's sprinkle some NaOH on it. Well, how much NaOH do we need to sprinkle on it? Well, okay, according to what we just figured out, we can melt 1 gram of NaOH, and each gram will give off 1,030 joules of energy. So 1,650,000 divided by 1,030. So 1,600 grams of NaOH. So again, let's think about what we just learned. If I go out and get 1.6 kilograms of NaOH and I sprinkle it on my driveway, it will give off almost 1.65 million joules of energy, which is enough to melt 5 kilograms of ice. Cool? And we do this kind of stuff all the time. First of all, don't ever put NaOH on your driveway. We put salt on it, not NaOH, but you get the idea. Okay? And then you can try this one on your own. How many grams of ammonia would I need to dissolve in 200 milliliters of water to lower it by 35 degrees to make it cold enough to put on my sore arm? So you would start with 200 mils of water, which is 200 grams of water. Q equals SM delta T. We just figured out M. S is 4.18 joules per gram per degree Celsius, and we want to lower its temperature by 35 degrees Celsius. That will give us joules, and then we can plug in what we learned up here. So I want you to finish that last problem on your own. All right, so if you're listening, we pretty much did this whole lab, this whole worksheet. Okay, finish it, get it turned in as soon as you can. I will be here tomorrow, Friday, and we'll go from there. Miss you guys, and I hope you guys are doing well.